Howdy there. We're going to do some more Punnett square practice. Let's read this introduction. A Punnett square helps scientists predict the possible genotypes and phenotypes of offspring when they know the genotypes of the parents. The phenotype is the physical appearance, pH, of an organism. So it's the way it looks. And the genotype is the inherited combination of alleles. It's the genes. This skill sheet will give you additional practice in using Punnett squares to solve genetics problems. Here's our first example. Rabbits. Black fur is dominant to white fur. So if you cross a capital B male with a capital B lowercase b female, what are the possible genotypes and phenotypes of the offspring, and what is the percent chance for each type? So we crossed a capital B with capital B lowercase b. Here are the possible combinations, and you can see we just write in the genotype as the letters, capital B. Because B is dominant, black fur is dominant, then if there's two capitals, it comes out as black fur. You can see there are two of those possibilities out of the total 4, so that's a 50% chance. And then you can see that there are two heterozygous genotypes, capital B, lowercase b. Since black is dominant, that's the capital B, so you get black fur for a heterozygous genotype. And you can see in here, there are 2 out of 4, which is a 50% chance. So now we're gonna do cabbage butterflies. In cabbage butterflies, white wings are dominant to yellow wings. So white wings would be a capital W, yellow wings would be a lowercase w. So if a capital W, lowercase w butterfly is crossed with a lowercase w, lowercase w butterfly, what are the possible genotypes and phenotypes of the offspring and the percent chance of each? So it's already set up as capital W, lowercase w for you, lowercase w, because that's what we're crossing. Mom and the dad. So I'm going to bring the capital W down and the lowercase w down. I like to put the capital first. So lowercase and lowercase. Now this capital W is going to go with this lowercase w, and this lowercase w is going to go with this lowercase w here. So I'm going to write down the different genotypes. So in this case, I have capital W, lowercase w. Capital W is the dominant, which is white. White wings are dominant, so it comes out looking white. And there are 2 of those out of 4, so that's a 50% chance. The other genotype showing up is lowercase. Because white is dominant to yellow, that means the homozygous recessive would be yellow. It's the only way you can get yellow is if you have 2 lowercase. And there's 2 of those, this one and this one, so that's a 50% chance. All right, if you're feeling good about it, you can go ahead and practice these on your own. If you want to keep going with me, you can keep going with me. In dogs, there's a hereditary type of deafness caused by a recessive gene. 2 dogs who carry the gene for deafness but have normal hearing are mated. What are the possible genotypes and phenotypes of their offspring and the percent chance for each? So if I have a capital D and a lowercase d, deafness is caused by a recessive gene. So that means deafness is recessive. So that'd be lowercase d. So not deaf would be capital D, or it could be capital D, lowercase d, this would be capital D. All right, so what are the possible genotypes and phenotypes of 2 dogs who carry the gene for deafness but have normal hearing? So as you can see, they carry the gene for deafness, this is the gene, but they have normal hearing, because being not deaf or normal hearing is capital D. And so this is the mom and this is the dad. So we're going to cross them. So this time I have 3 different genotypes. I have capital D, I have capital D, lowercase d, and I have lowercase d. So being not deaf or normal hearing is dominant. So you get it here and you get it here. And the only way you would be deaf is if you had homozygous recessive. So the chance of having normal hearing with a genotype of capital D is 1 out of 4. So that's a 25% chance. For normal hearing heterozygous, it's 2 out of 4. So that's a 50% chance. And for deaf, it's 1 out of 4. So that's a 25% chance. If you think you're getting it, go ahead and keep working on your own. If you want to keep working with me, you can learn about guinea pigs. In guinea pigs, short hair is dominant over long hair. So capital S is short hair. So you can get that if you have these 2 options. Long hair is recessive. So the only way you can get that, see if you have 2 lowercase s's. So if a short-haired guinea pig is crossed, so that's this one, is crossed with a long-haired guinea pig, that's this one, what are the possible genotypes and phenotypes of their offspring and the percent chance of each? Make sure you really make your big S's big, otherwise it's hard to tell the difference. So I only have 2 genotypes. I have capital S, lowercase s, and I have, well, that's it. So the phenotype would be short hair. And that's a 100% chance. I don't know why they have this here. There are no other genotypes. All right, I'm not going to do any more with you. You will have to do it on your own, and I know you can do it. Peace.